Hello, and thanks for taking the time to listen to Reimagining Cyber. New episodes of the podcast drop every Wednesday. So to make sure you never miss a show, do hit the follow or subscribe button wherever you listen. You can also find us on the @Reimagining Cyber YouTube channel. Hello and welcome to Reimagining Cyber. I'm Rob Aragao. This week we've been inspired by the historic Artemis II mission to the moon to revisit an amazing episode we released last year about cybersecurity in space. It features Tiffany Snyder, who was then Deputy Chief of the Cybersecurity Mission Integration within NASA, and she's now a program specialist at the Space Communications and Navigation Program. Tiffany joined NASA in 2018 with over 20 years of IT and cybersecurity experience, including time in the Air Force Space Command and as a special agent within the Department of Defense. I started by asking her if working at NASA had always been a career goal.
Oh, I was a kid of the 80s, right? So I wanted to be an astronaut. I grew up watching shuttle missions. I was very interested in astronomy and science in general. And when I decided to go into college, I actually started with an earth science degree and didn't have a way to pay for it. So I joined the Air National Guard to pay for college. And when I was in the recruiting office, the recruiter asked me, "Hey, are you interested in a non-traditional female job?" And so, of course, I was like, "Well, what does that mean?" And she said, "How about civil engineering?" And I had no idea what that was at 17. And when she explained it, I was like, "I don't know if that's for me." So she said, "How about computers?" And I was like, "Computers? Okay, sure." And so that's how I ended up in communications computer. I was a communications computer systems operator within the Air National Guard. And that's how I paid for college. But after I completed my degree in earth science, I really didn't have a plan. So I took a position within the Air National Guard Space Command unit out in Colorado. And I was a full-time information technology specialist there for years. And that's where I really began to hone those skills with cybersecurity as to how it pertains to space communications. Fast forward 6 years with the Guard unit there. And I was offered a position with the Department of Defense in cybersecurity, moved to Melbourne, Florida, right down the road from Kennedy Space Center. So this entire time in my career, I don't know that I actually had the goal to work at NASA, but, kind of always had that eye, NASA is a possibility.
There was an interest there when you were younger and the path ultimately led you there. It's great to hear.
Yeah, exactly. So after about 8 years in cybersecurity with the Department of Defense, really working at applying cybersecurity to weapon systems, naval systems, air systems, a position opened up at Kennedy Space Center working on the cybersecurity program. And I was fortunate enough to be offered that position in 2018. And I've moved around a couple times at NASA, but now I work primarily with cybersecurity mission integration at the agency.
Excellent. Appreciate that background and the path that you took to get here. Let's jump in and talk about, at a high level, in essence, some of the key elements that are taken into consideration within NASA to ultimately protect its mission critical systems and the data, obviously, as well. So can you get into a little bit of that, if you could, just kind of focus at a top level?
Sure. I would say at NASA, it really all begins with understanding the goals of the mission and the constraints that our various missions operate under. Taking into account who the customers are, who the stakeholders, who our partners are. NASA has such a diverse and large portfolio of missions, anywhere from maybe a $10,000 weather balloon, right, that's only going to operate for 2 months, to a multi-billion-dollar campaign like Artemis that we hope will operate for decades. And we oversee the cybersecurity program for all of that. So that's really hard to come up with like one overarching cybersecurity program that's going to work for all of those types of missions. So fortunately for us, NASA already has a robust risk management function baked into every step of the missions, right? From the very beginning of system development lifecycle, our mission personnel, our engineers, our software engineers, safety, they're identifying, categorizing, cataloging risk. When you're building the world's largest rocket and sending people to the moon, you really have to have a spot on understanding of risk. And you need to understand what systems and data are critical and what assets are critical, what absolutely cannot fail. So saying all that, I think it's hard to think of anywhere else in the world that manages risk quite like NASA at launch control, mission control. I will say that cyber is the new kid to the block with risk management as far as NASA goes. If you talk to somebody in our field about risk management, we're obviously going to think about risk management from the risk management framework perspective. I know you've had Dr. Ron Ross on a bunch of times from the NIST, right? Very smart guy. And the NIST puts out some amazing publications on risk management. But honestly, NASA's risk management function predates a lot of those publications. So we've had to evolve our approach in cyber, and as opposed to asking the missions to do our framework, we've had to think about how can we fit within what they're already doing so well. Right? How do we bring that cyber critical information to our program managers, to our flight directors in actionable terms, because they are managing so many other areas of risk. When you're talking about on launch day, launch control here is thinking about weather, they're thinking about bird strikes, they're thinking about metal fatigue. I can't come to them and say, you have 1,000 unpatched systems on your network. That means nothing to them. From their perspective, they're thinking, what does that mean to the success of my mission? Tell me, what do I do with that? So we've had to evolve our process so that we can jointly work towards protecting these critical assets. And it's a struggle when you're a federal agency and you have somewhere over 140 pieces of legislation telling us what we have to do from a cyber perspective. And then you have to communicate this in a way that is effective to our mission personnel. And we're still working on that, I will say.
You're always going to continue to work on that. I think one of the things you said as you were initially responding that triggered for me is we've had many conversations that have been much more kind of focused on, the private sector and business functions and whatnot. But you said it right out of the gates as well for the world that you live in, which is you have to understand really the mission. You have to understand the key stakeholders and the desired outcomes, in essence. So at the end of the day, it's all the same. It's how you translate. And as you also were saying, the right kind of verbiage in your conversation to get the point across as to, again, in this case, what the risk could be to that mission as an example. So I think those are all good, strong aspects to help kind of continue to evolve cyber's kind of place, in that understanding of risk. Now, I wanted to talk a little bit about collaboration, and obviously within NASA, there is a ton of collaboration within, our own government agencies, but beyond the scope, dealing with international, right, governments, and just kind of, I guess, even into the private sector side of the equation. But just how does that kind of flow? What are some of the different kind of experiences you can share there? I'm sure there's tend to be sometimes kind of barriers in the communication and what you can share, what you can't share. So just kind of, if you can walk us through that, that'd be really helpful.
Yeah, sure. I mean, a lot of how we're going to collaborate with our various partners is going to depend on what kind of contract or legal agreement is in place often. Like you talked about some of the various partners we might collaborate with. We obviously collaborate within the U.S. government very easily. NOAA, Air Force, Space Force, FAA, right? The FAA has a lot to do with space travel, surprisingly. So we can share cybersecurity information back and forth between these communities pretty easily. And then in places where we are interconnected, of course, we have like interconnected security agreements where we both agree to share information. When we talk about maybe like commercial partners, we would write some of that into the contracts. We have space act agreements for a lot of folks who are going to use our information, our infrastructure. And then when we move on to the foreign partners, a lot of that's also going to look at how are we collaborating with these foreign partners. We collaborate a lot with different space agencies, and that's really going to depend on which mission we're talking about. A really current example is space station, right? We often have crew members on space station from other agencies, and a lot of that is handled on mission control in Houston. And when we're taking data from other crew members, we have to consider what are the legal frameworks for how you handle that kind of information in different countries, making sure that we are disseminating that to the right people, making sure that they're also handling any information they have on our crew members in the correct manner. And a lot of that's grown organically, because a lot of those relationships were in place or predate cyber regulation. So we're kind of modeling our way through it as we become more interconnected with commercial partners.
It's part of it, though. Again, we've had a lot of different discussions around, well, there was one very recently around cybercrime with Craig Jones, who was the most recent director of cybercrimes at Interpol. And it was, think about like close to 200 countries of how do you exchange information and effectively, and you got to be careful in managing some of those relationships. So it's a similar principle, different scale, but again, similar principle. So it's very pertinent to success, especially around cyber. Now, another critical aspect, I think, as it relates to cyber, especially obviously in the world that you're living in every day, is just how do you really kind of protect, maybe detect, but also protect, obviously, against supply chain type of attacks as it relates to the spacecraft, all the different equipment that NASA has to deal with.
That's another area I would say that we've had a really long storied relationship with supply chains at NASA. Traditionally, it was supply chain risk management was handled at the programmatic level or maybe at the center level. And, obviously that's not the most effective use of resources. So we've consolidated a lot of that work to an agency perspective, making sure that we're looking into supply chain risk from, making sure we don't have counterfeit parts, that we're a government agency, so we need to comply with trade regulation. But from more of the cybersecurity perspective, I think we're all seeing that it's very difficult to protect against that, and maybe focusing more on mitigation, right? Yeah. So those maybe that Cyber 101, having those basics,
good hygiene.
Right, good hygiene. Yeah. What assets do you have? Who has access to them? So that when the next vulnerability comes up and I have leadership looking to me, do we have that in our environment? I need to be able to say with some level of certainty if we do have it, and if we do have it, or we don't have it. And if we do, where is it? Is it in a critical asset? Is there something we can do to protect or mitigate?
Makes sense. I wanted to get a little bit deeper into data. You talked about data from the perspective of kind of the individuals, right? And data that maybe other countries may even have in those individuals as part of the crew, if you will. But just kind of how do you deal with the balance of open data initiatives, especially from the research side, right? Because obviously there's tons of research that happens within NASA. I've seen it a lot more so in higher ed and the, let's call them debates that are happening with the researchers and all the open access they need to information flow. And anyways, again, let's call it a debate. How are you dealing with some of those things? How are, kind of some of the core security principles, requirement controls put in place to help balance that request, if you will, that need?
Yeah, it's very complicated, to say the least, because we are a science organization and we have a very strong research background, but we also have space operations, right, that are a little more sensitive. So we do have to work closely with mission partners to understand the different data handling requirements of what they're doing, what they're producing, because we have that human space flight element where we tend to work more with commercial partners or other government agencies. And maybe we're handling more proprietary or sensitive data. And then we have the research arm of NASA and the science mission. And under the science mission, we operate under I think it's called the Open Source Science Initiative. And that's where we have committed as an agency to make available to the public anything that's funded by the public, right, in a manner that's transparent, inclusive, accessible, and reproducible, right? So we have the Science Mission Directorate at NASA, and they have put out internally publications on how to make sure that anything that is publicly funded is publicly available. I would say that NASA has put out a lot of science. I don't know if you've spent any time looking around our websites. My favorite from an earth science background, right, is earthdata.nasa.gov. And that's where you can go see all of that Earth observation data. We do make it publicly available. So within the agency itself, there's kind of a split, making sure that we take all that research data, that science data, make it available to the public and researchers as soon as possible with as much integrity as possible. And then we have that human spaceflight element where we handle more like in a typical corporate structure where it's protected. And then, of course, as a government agency, we're also beholden to all the laws around government data. We have records requirements, we have CUI requirements, how we handle privacy information. It's complicated.
A lot going on. There's no question about that. So this next question I have, it's kind of a two-part, looking at it from both the space side and then ground control systems. So what you can share. Kind of what are some of the, and you talked about this earlier, we kind of said, that good foundational security hygiene put in place. But what are some of the kind of focus points of protecting, right, satellites and spacecraft, and then also looking at it from the ground control systems? Like, what are some of the things that you're doing, again, what you can share, both kind of aspects of that, again, in space as well as ground control?
Again, I'll point to the realistic fact that our portfolio is very diverse, and that makes it challenging because we do operate in all those domains. We operate in space, we operate in air, we also operate at sea, and that might surprise people, on every continent. So it's incredibly challenging. Also taking apart the myriad of legislation and executive orders that we have to contend with. So those close collaborations with mission partners, having that good understanding of what their goals are and working backwards from that. Cyber 101, I wish it was a little more interesting in that. But I will say that some of the challenges are trying to retrofit cybersecurity around aging spacecraft is obviously challenging. And is it even worth it from a funding perspective? We have to take a look at each mission individually and talk about what does it do? How does it meet? How does it fit within the goals or the strategy of the agency? And how many resources are we going to put towards securing it? Can we segment it away from operational networks? Do we discontinue using it? And then where we want to keep something operating because it's giving us that good science or it's a flagship mission, then working with those mission partners to say, hey, walk us through your operations and looking for those opportunities to harden where we can and segment away when we can.
You just brought up an interesting point that I kind of wasn't taken into consideration, and it reminded me of another episode we had a while back, actually, around, it was with Idaho National Labs. It's around industrial control systems and the aspect of newer systems and having the embedded security control mechanisms put in place, obviously a heck of a lot easier than going through some of the legacies. And as you kind of alluded to, obviously same principle makes sense for some of the things going on at NASA. It almost comes to the point where it's, kind of, again, the associated risks and the costs of, do we go back and deal with some of that legacy? Maybe it's not quite legacy type of infrastructure, if you will. I guess it's just a really interesting connection point, and you have to kind of take that into account as part of, again, the decisions being made going forward. So is there an example that you have that relates to anything similar to that? Like, or actually, are you seeing better embedded security controls in newer technology that NASA is actually launching?
Yeah, absolutely. I think there's been this move across industry for that secure by design, secure by default, right? Cyber resilience,
right.
800, 160, thinking about how do we build trusted systems? How do we build systems that have security on without, as opposed to in the past, we would see vendors just kind of throw things out there with that understanding that, we'll just patch it later.
The bolted on approach.
Yeah, exactly. So we are moving towards that. I think we're going to see going forward engineers who are more security minded and security folks who are more engineer minded. So we can have that secure by design, secure by default kind of mindset going forward.
Good. Makes sense. Last question for you. It's kind of looking into the future from your perspective, some of the things that maybe you and your teams are taking in consideration now to better secure cyberspace going forward. You've mentioned some of the things, but just, is there anything different, anything new that's kind of really interesting that you wanted to communicate out there?
I think, in our field across, we're all kind of interested in AI, right? AI, what is that going to do for us? What are the opportunities? What are the drawbacks? I think as an agency that produces a lot of data, there's a lot of opportunity there for AI to make that data more useful. And from a cybersecurity perspective, right? Everything from AI is going to make the overhead of doing security assessments a lot easier, but, hack in the box kind of worries. Anyone with AI, at their fingertips can be a potential menace for all of us. What they're calling the democratization of space is going to be very interesting. There's a lot of opportunity there. It's going to make maybe somebody like my job a little harder, as we have more people, the threshold to get to space is going to be so much lower that we're going to have a lot more private commercial space operations. And what does that look like for an agency like NASA? I'm excited to see that, though, because I think when you have a lot of people entering a new domain, it really generates a lot of innovation in the field. Our reliance on commercial off-the-shelf software and hardware in space, I think, is another area that's going to drive innovation, but could potentially increase vulnerabilities.
Many things to look into, right? And well, listen, Tiffany, we really appreciate you coming on because it gives us kind of the behind the scenes as much as you can share on how cybersecurity is playing a critical role moving forward in NASA. It's great to hear, how things are being looked at. It's great to hear the aspect of how you're working through and embedding cybersecurity aspects into the risk management frameworks as a whole within NASA. Again, no easy feat. So truly appreciate you coming on and sharing some of the different experiences, the path you took to get here. And we're looking forward. This is obviously a very interesting area for focus for many different people that are listening in. So appreciate having you here today.
Yeah, thank you for having me.
That was Tiffany Snyder from NASA. Thanks for listening to Reimagining Cyber. We'll be back again next week to delve into the revelations held within OpenText's 2026 Cybersecurity Threat Report. Goodbye for now.